Hi and welcome. Now before you proceed further with this video, please make sure that you have your 2 pages for this lesson printed and in front of you. The 2 pages look like this page that you're seeing here and this page. At the bottom right hand of the page, you will see how many pages are in each PDF of notes that will accompany the lesson videos. Alright. Now this course contains 5 video lessons, including this one, with printable notes for each, 2 worksheets with solutions, and 1 quiz to submit for correction. Now please print the notes and use it when viewing the lesson videos. Extra spaces are purposely left for you to fill in the extra notes and working as seen in the lesson videos. Now here you will see the 4 objectives in the syllabus that you need to complete in this topic. And at the end of all 5 video lessons, you should be able to perform these objectives here. Alright. Now here are some topics on the right hand side here that you should have completed in mathematics in forms 1, 2, and 3 and early form 4 before you're able to do this topic. Now some of the topics that you need to be proficient in is working with algebra, solving simultaneous equations, directed numbers. So directed numbers are adding negative numbers to positive numbers or adding negative and negative numbers, etc. Factorizing, including quadratic equations, and the 4 basic operations of fractions. Alright, you need to know how to add fractions, subtract fractions, divide fractions, etc. And you need to know how to work with indices and exponents. Now in this session, we will revise and practice some prerequisite knowledge for algebra. So from your mathematics classes, you should already be familiar with working with algebraic expressions and equations. So let's recap some terminology. There are 2 types of expressions in mathematics, numerical and algebraic. Numerical expressions are mathematical expressions that contain numbers and mathematical operations only. So what do I mean by mathematical operations? These are operations such as addition, subtraction, multiplication, and division. So you need to know how to do these things proficiently. Of course, you have your calculators to help you along, okay? Calculators are allowed in your paper 2s and your paper 1s that we spoke about in the student info sheet. Alright. Here you have your numerical numbers and here you see your mathematical operation. Alright. Now notice that this is called a mathematical expression and not a mathematical equation. The reason being there is no equal sign here and no equivalent answer here. So this here is just an expression. Now an algebraic expression are mathematical operations that may contain numbers, alright, so numbers like these, but must have at least one variable and a mathematical operation. So do you remember what variables are? A variable is a letter or a symbol that represent a number. Alright, and that number or symbol or letter is varied. Okay, it can change. Alright, so let's look at these examples here and let's identify what the variables are. In the first example, we have x plus 2. Your variable here is this x. Alright, it's a letter used to replace or to represent some number that we do not know. 6r plus 12. Your variable here is the r. A plus b. You have 2 variables here, a and b. 9x plus 5y squared plus 8. Here we have 2 variables as well, x and y. Now let's further examine 9x plus 5y squared plus 8. Each one of these here that are separated by a mathematical operation is called terms. Alright, so in this case here we have 3 terms. And your x here and your y here are called, we just spoke about that, variables. The 9 and the 5 in this expression here, these are called coefficients. This 2 here is called your exponent, an indice, a power, or a degree. So these are the different names you would see and hear being used to represent a number on top of a variable like this. We also have this number here, and this number here with no variable on it is called a constant. So the value of the 9 and the 5 doesn't change. However, the value of the term 9x and the value of the term 5y squared changes as x and y are varied. Now, here you might want to pause the video and take down these notes before you move on to the second page. So here we are on page 2, and we are going to talk about something called like terms. So we identified what terms were on page 1, right? So now we're going to talk about like terms. Now consider the expression to simplify. 2x plus 4y minus 5z minus 5x minus 9y minus 7y minus 2z minus 8z minus 5z. Alright, so here we have terms that are separated by a mathematical operation. Now, in order to simplify, so here you see the word simplify, right? Now you would find that term, simplify, you would find the meaning of that term in your glossary that we spoke about in the student information sheet. Now if you have not seen that video, please go back to in this classroom where you see start here, you would see that introductory video. Alright, so please go back there and look at the glossary to help you understand what you need to do and how you need to answer your questions. Alright, so to do this, step 1 will be to rearrange and put like terms together after applying BODMAS if necessary. For example, expand any brackets. Now in this case, we have no brackets to expand. Alright, so we are going to just rearrange this and we are going to put like terms together. So let's start on one end. Let's start with 2x. Alright, so 2x. Are there any other x's? Yes, we have 5x. But it's not just 5x, it's minus 5x. Alright, so the sign or the operation in front of the term goes with that term. Now the 2x, a positive operation, right, can be assumed there. The 5x is negative 5x or minus 5x. Are there any more x terms? No. Alright, so let's look at the y now. We have positive 4y. Do we have any other y terms? Yes. And we have here a negative 9y. Okay, so we're going to put negative 9y. We also have a negative 7y, and we have no other y terms here. Now we are at z's. We have a negative 5z, and we have 2z, 8z, and 5z. Now it's not just 2z, it's positive 2z, positive 8z, and negative 5z. Now step 2, perform operations according to BODMAS. Alright, so here we will perform these operations from left to right because we only have addition and subtraction in this expression. So 2x minus 5x. Now here's where your knowledge of directed numbers will come in. Okay, so 2x minus 5x will give me minus 3x. So we're going to look at all the y's, which is this. Okay, so 4y minus 9y will give me minus 5y. Minus 5y minus 7y will give me minus 12y. Okay, now let's look at the z's. We have minus 5z plus 2z plus 8z minus 5z. Let's see. Minus 5z plus 2z will give me negative 3z. Negative 3z plus 8z will give me my positive 5z. And positive 5z minus 5z will give me 0, right? So our answer is only minus 3x minus 12y. And this cannot be simplified any further. Okay? Now, before we move on to the next section, which is polynomials, complete question 1 on section 1A, Algebra worksheet number 1. When you completed that, check your answers with the solutions provided. When you finish with that, come back to the video and move on to polynomials. So now that you completed question 1 on section 1A and you checked your solutions, let's look at polynomials now. 3a to the power of 4b is a monomial because there is one term. Alright, do you see that there is no addition and no subtraction or any other mathematical operation before or after this? Okay, so which means this is just one term, and we call a one term a monomial. A plus b is a binomial because there are two terms. Okay, you have the a and you have b. 2x squared plus x plus c is a trinomial. Is also called a quadratic. Alright, it's called a quadratic for reasons that we will discuss in section 1b in quadratics. So that's in another lesson. Now, the expressions with variables that have fractional or negative exponents on them are not polynomials. Alright, so if you see anything like this, 2 divided by x plus 3y plus 2, these things here are not considered polynomials. The square root of x plus 3 plus y is another example that is not a polynomial. Alright, so these are not polynomials. Now let's talk about a degree of a polynomial. The degree of a polynomial is the maximum degree of all the terms or monomials in a polynomial. Sounds confusing, right? But with some examples, you will see how easy it is to find the degree of the polynomial. Now, the degree of a polynomial can be found by first determining the sum of the exponents of the variables in each term or monomial in the polynomial. Then, we would choose the value with the highest degree. We do not consider constants and coefficients when finding the degree. And we combine like terms first if necessary. So let's look at these three examples here. We have x to the power of 4 plus 7x to the power of 3 minus 2x. Now, we have a 4 here. So in this monomial, we have a 4. In this monomial, the only exponent is a 3. And in this term here, or this monomial, the exponent is a 1. So we have 4. We have 3 and we have 1. Now we choose the one with the highest value, which is the 4. So this 4 is the degree of this polynomial. Now let's take a look at the second question. We have a squared plus 5a squared plus 3a to the power of 10. Now here we can see we have like terms, right? We have an a squared here and an a squared there. So 1a squared plus 5a squared will give me 6a squared. And then we have our 3a to the power of 10. Now our exponent values here are 2 and 10. So our degree of this polynomial here is the highest value, which is 10. Now question 3. we have minus 4p cubed plus 5p squared q to the power of 6 plus q to the power of 4. Now here we see we could cancel off the coefficients because we don't need those. This first term here we have p cubed, so we have a 3 there. This second term we have p squared q to the power of 6. Now, according to your note, we determine the sum of the exponents of the variables. So the sum here is 2 plus 6. Even though they are not the same variable, we're still going to add the sum of the exponents. So 2 plus 6 will give me 8. Then we have q to the power of 4. So this term here is just a 4. So now we could identify our highest degree, which is 8, and 8 will be our answer for the degree of this polynomial. So now you can move on to questions in question number 2 in worksheet number 1. Be sure to check your solutions with the solution sheet and make sure you understand exactly what we did here, and I'll see you in lesson 1.